Okay, so basically I have gave you all the video regarding the genetic algorithm last 2 weeks, right? So any question? That one is in terms of the fundamental knowledge of genetic algorithm. So today I would like to show you or to share our my knowledge, how we want to program GA in MATLAB. So my PhD, I'm doing PhD. I'm using GA in my PhD to solve the power system problem. So what I've done is applying the genetic algorithm as an optimizer to optimize the parameter of support vector machine to solve power tracing problem. Okay, so if you go at my website, I think you can see various papers that I have published in power tracing during 2007 2012 like that. So there is several ways how you can program your genetic algorithm program in MATLAB. So there is a shortcut and there's a long cut lah. So which one you all prefer? Long cut meaning that you need to develop GA from scratch from M file. So that one I really propose because that is what I have done during how I want to understand how the program is developed, and I really want to know to learn programming in MATLAB. So that's why I refer one book that I have said previously. It's a very good book. I think I put in the slides. Oh, no, not this one. You can see, you can get the book. I think the ebook. If you go for the Google, Google practical genetic algorithm how. Okay, this one I think you can get the ebook. Randy and Sue Ellen Haupt. Oh, this one you need to request. But I think I have the book. Wait check. Mana tak ingat. Book. This one is not. Tak ingat tapi saya I think I have saved in Google Drive. Yeah. Ni Xin Yang, also Yang is the authors or the inventor of firefly algorithm, flower pollination, and I think quite a numbers. But I think last time I have saved. Okay, Yang is one of the well-known authors. Xin Yang, I think genetic algorithm also have, but I think he just give a pseudocode, not the program. But he share a lot of about the firefly, and then program you can obtain at the MATLAB. Wait, I try to look at the Randy Haupt. Mana? Ibu yang tadi sini. Satu. This one. Ada ke dia? Vertical genetic algorithm. Ada dekat file ni. Oh, here. I have it. Practical genetic algorithm. So I can share with you all. So this one is ebook. During my PhD time, I borrow at library Unimap. The first edition. This one is second edition. So it's a good book because it discuss in details about the genetic algorithm than the applications. Okay, and then the beauty of it is even I think if you buy the book online, you can get the MATLAB code. But the beauty of it share the program in MATLAB. But during that time, I type one by one. I type it at MATLAB one by one in order to MATLAB code. So I just retype it and then I run and then there is no error. So this is the beauty. So this one is very good book. You can use this one for to understand in details about the genetic algorithm. Okay, whether it's a binary or continuous genetic algorithm. So later I upload in WhatsApp because it's about 5 meg only. Okay, so and then you can use this program in your assignment number 2, or you can learn. You can use what we call it a toolbox. So if you go at Google, you type genetic algorithm solution and directly to solve economic dispatch, you can get this file. This file basically what he done is he programmed how we want to use the MATLAB toolbox in GA toolbox in MATLAB. Terbalik. Okay, so here is the program you can download. So basically you need to know how to do it. So firstly, if you get the file, you get I think 4 M file consists of ELDGA and then we GA test 1 and I think ELDGA 1. So this one how they program in function. So let's take a look. Which one you want to prefer? To use the toolbox or program from scratch for today class? For the class today.
Toolbox nanti ada.
Toolbox okay, tapi you tak tahu apa yang berlaku dalam tu lah.
Oh,
so, okay. Basically you need to learn. Okay, basically I just show you how to use the toolbox. Basically, MATLAB has developed GA toolbox, so you can change, but you need to learn how the toolbox is operated. Okay, so basically, if you look at this example, if you can download now the file. Okay, so later I just share in group. Mana tadi? Saya tahu kat mana. Not this one. Okay, this one GA. This one GA exercise. No. Basically, you can find numerous. Saya nak buat ni. Saya tak boleh compress. kena buat file ni. Share folder boleh lah dekat website, dekat WhatsApp. Where is the WhatsApp? Dokumen je kan? Tak apa, so I share document, try attach. Share the document. These things. Mana tadi? Oh, bukan sini. LDGA. So you need to put all the file in the same folder. Okay, so you can open the, I think this one is the introduction lah. The paper ataupun I'm not sure, I think it's paper, his paper. This guy. Okay, this is what we have learned about the economic dispatch, but this one is a simple one. So we have quadratic function, and then this is we use the BM coefficients. Then this one we have how he done, because we need to control, we need to make sure that this one is, they call it penalty functions. Okay, this is penalty functions, and this one is the summation power minus the demand minus the loss. So this one, when your power is not equal to this, because we know that our power our summation of power must be equals to demand plus loss kan, P loss. So when you do the GA, this value sometimes is not equal to demand plus loss. So how we want to control it? This one we call it equality constraint. Equality constraint. So how we want to control it? We implement the penalty function. This one is penalty function. So when this is violated, it become very, very high functions, meaning that, let's say you do the calculation of the cost function, and then you need to add with the penalty function here. So let's say there is an error about a 20 error times 1000 is 20,000, right? So make your objective function become higher. So at the certain, throughout the iteration, so this one will be minimized. So let's say there is no error, because your PI is, let's say your PI, summation of PI is equals to demand and loss, meaning that when you minus these two, you got 0. So 0 times 1000, is a 0. So that's why this is the function, we call it objective function. Objective function with penalty function. This is 1000. Okay, this is implemented in the program. So the example is taken from Hadith Sadat. So as you can see, you can read this thing. And the beauty of it can plot very smooth, very, very nice. It's nice plotting, and you can get the results there. So let's take a look. If you have MATLAB, you can run it together. Let's take a look how he done this thing. First, this is the main file. GA test is the main file. Okay, this one is using MATLAB 7, no problem. And the data is, I think, obtained from the Hadith Sadat. So this is the row, right? And this is the column. Column number 1 represent the coefficient A. Column number 2 represent B. Column number 3 represent number C. Column number 4 is the lower limit. column number 5 is the upper limit of the, and then the row denote the number of plants. So this one we have 1, 2, 3, 4, 5, 6. So we have 6 generators. And then it also have the B loss coefficients. This one, B loss coefficient. So the demand for this power system, the 6 generator is 700. So we want to find the optimal value. So here because there is an embedded of genetic algorithm problem toolbox. So you need to set the GA. This one is option GA optim set. This is how the program, because you need to make sure that your optim set is put in the options. So what we want to use this thing. So this is how the program. The first one is population size. Okay, the second one is generation. Generations meaning is iteration similar. And then time limit is 200. Store time limit 100, and then there's a plot functions. This is how you want to plot your GA. Okay, so this one is GA plot best transfer best function, and alias GA plot best individual. And then how we want to do. So you can basically GA optim set you can change. So you can go to MATLAB. You just press help GA optim set. Okay, you type help GA optim set. Explore all the set that you can create or you can alter. So you can learn here. So GA optim set is basically you create or you alter the GA options structure. So GA optim set returns a listing of the field in the options structure as well as the valid parameters and the default parameter. So this one is how they give the example how you want to program this one. So you can say this, look at here. It's like here options equal to GA optim set param value. Okay, param value creates a structure with the default parameters. Use for the all param not specified, and will use the pass argument value for the specified param. So basically, if you don't set, it will use the default value. Or you can set this one if we have one parameter only. So let's say you want to set the parameter 1, parameter 2, value, and so on and so forth. So you can set this thing. So this is how you program. So as you can see here just now, what this guy do is set the population size 50, the generations 50, 500, time limit 200, stall time limit 100. I think this one is 1. If there is no changes or no significant change after 100 iteration, it will stop. Okay, and then this is how the GA is created, where your X is your value of your input, meaning that the generation number, generations. Let's say you have 6 generations. So what is your X is the generation. What is the value? The best value until the maximum, the best values. I think FF is your fitness function. So 5 need to check back. So you can, if you don't know what is this mean, so you can type help GA. So because the toolbox is embedded in the MATLAB toolbox, so you just help GA. So basically, if should be no problem because the GA is the toolbox for GA has been developed. So GA is the constraint optimization, okay, using genetic algorithm. So GA attempt to solve problem for the living form. So this one is you minimize the objective functions subject to this one, the linear constraint. This one is non-linear constraints. Okay, this one is your equality constraint, right? So A eq X B eq. This one is normally is your equality constraints. But sometimes we need to teach or we need to tell the GA to make sure that they use the one. So let's say let's take a look here. So XGA fitness function and VAS. This is how the program. GA fitness function and VAS. And VAS is number of variables. Or you can use X, GA, fitness function, numbers, and vars A, B. Where is your A and B? This one, A. B, I think, define the local minimum X to the function, fitness function, subject to the linear quality constraint. This one, A, X, B, this one. Or you can use this one, X, GA, fitness function. Okay, so let's take a look back what this guy have done. It's just 5 thing options. What the options we embedded here? 5, I'm not sure what is 5. Let me check. Because we have 6 generator, right? 1, 2, 3, 4, 5, 6. Wait, this one. This one 2. I think this one is okay. I know. 5 because of you need to find the. Even though we have 6 generators, one is the we call it the slack bus, right? Slack generators. So that's why I use -1. So meaning that this GA function will find 5 results and the 1 is the dependent results in order to make sure that you obtain the 1 is the slack bus, slack generators. So let's take a look how the program. So basically when you have problems, you can use GA toolbox. Here is GA toolbox. But the important thing is you need to give the GA the objective function that you want to solve. So that's why they put here this is function name ELDGA. Okay, this one is function name ELDGA. So you open the ELDGA. This is the objective function file. So the objective function file is you want to find your F. I think P1 is your power output generators. PL is the loss, transmission loss. So you just call back what your X. This is your X. Your X is your random number. I think this one have been done in the GA toolbox. So this is how the program. And if you look at this data, basically, this data n is length of data column 1. The length of column 1 we have 6. Okay, and then this one is your how the calculate the P, right? Because you want to calculate the P data I plus 1, meaning that let's say this is 1 plus 1 is 2, right? 2 4 1 2 3 4. Okay, this one is want to find the minimum and maximum to make sure that your power that contribute from the X value is not over the limits. Okay, this one. B, basically this equation is to calculate the I think it's one to calculate the loss function. Okay, and then C is the summation of the PD demand minus sum B. This one basically is your loss. Finally, when you get the P, this is your function, where your function is your P times P square, right? Alpha times P square plus beta times P plus C. This is the equation of this equation. This one. Okay. Okay, and then this one is your P loss. P loss is P1 times B plus P1, and this one is how they manipulate the data to get the loss. So lum is the number, is the what we call it the error, or suppose your lum supposed to be to get 0. So like I said previously, because this equality constraint is hard to control. So that's why lum is the error between your generator as well as your load. Suppose we must get Pi equals to Pd plus loss, right? So lum is the absolute sum power that you have contributed, calculated by GA minus PD minus loss. This one is loss. Okay, and then you get the F sum F1 plus 1000 lump. This one is this equation. This one. So this one they call it lump. In MATLAB, we give number lump. So if you run, supposed to be don't have any error. So you need to run from the GA test here because this data is obtained here. So if you run this thing, okay, there is a, so as you can see here, you set the maximum iteration is 500, but it stopped until I think less than 150. Okay, but as you can see here, this is a current based individual. You have 1, 2, 3, 4, 5, but I think this one is got error because you got negative variables. Never mind, let's take a look what is the result is about. So this is the results: P1, P1, P2, P3, P4, P5, P6. So you can verify these things. Supposed to get the similar value F 8000. This one is the function. Okay, this one is your optimized value. This one is your loss. Okay, that's all. That's how they use the GA from here. So let's take a look at the example number 2, GA test 1. This one is, you have 3 generators. Okay, so this one how you want to optimize 3 generators. I think you can get this one example 7.8. So if you run these things, so until I think less than iteration, so you can get here it gave the result 2 value, right? So meaning that this is P2 and P3. P1 is here. P1 is calculated here because P1 is said is the slack generator. So let's say you sum this thing. Dapat berapa? 1525717 this one is generator, right? So supposed to be your demand is where is your demand? Tak tulis demand berapa. Pelik. Ini data A, B, C. This is the BO. This is a B loss coefficients. Where is the demand? Tak buat demand. Kalau yang ni betul ada demand kan. So ada PD 700. Tak cakap berapa demand. Hari Sadat, buku Hari Sadat tinggal pula kat office. This one PD tak bagi. Let's say we have PD 3 generator. Let's say PD we put 250. So if you run, okay, you get these things. If you sum, supposed to be to get 250 plus something 252 something. 250. Okay, so 152 because 2.6284 is 6 is the loss. Okay, because your P generators must be equals to demand. Your demand 250, price 150 ke 50 saya buat tadi. Oh, tak betul. Okay, let's take a look here. 8, 16 campur 7, 230 tak boleh. Because dia is not enough. Let's say we have 200. This one is maximum, this one maximum. Okay, try to run again. Something wrong here because it's negative, but never mind. So let's sum this thing. $150. Tadi kita buat berapa? 200. Tak dapat agak ni. So this is the problem when you do the toolbox. Sometimes you cannot get the answer. This is wrong. Suppose just make here the GA. Wait lah, kita tengok. Oh, dia buat demand kat sini 150. Okay, silap. The demand has been put here, ADGA. So let's say we have put your GA here is 200. So you run, get 200. Okay. Okay, 204. So meaning that generator 2 and 3 give the maximum value. The rest is supplied by the slack generator. Okay. So you get 204 total generators. Your load is 200. Your loss is 4 megawatt, 4.6 megawatt. So this is the 3 generators. Okay, can you understand what I've done here? Boleh dapat tak? Mana tadi? Okay, can you see how it has been done? This is what you using the GA toolbox. Okay, you can change the toolbox here because this one is 50 generators populations. So this one is 500. You can change this value. Just never mind. But you need to make sure that you arrange your data is accordingly. Okay, so the first column is your A, second column is your B, third column is your C, fourth column is your minimum value, and fifth column is upper limit. Okay, this is 3 generators. This is 6 generators. Okay, any question, class?
Nanti kena tengok kat sekali.
So that is how you can use MATLAB toolbox. Basically, you can program. Okay, the problem is what? The problem of when you have the problem, you want to calculate any problems, not only for genetic algorithms. The problem is how you program your functions, your objective function. This one, ELDGA. This one is LDGA, this one is LDGA1. So how you program the functions to solve the problem. So this guy, I think this function or this economic dispatch problem you can get in a lot of program in MATLAB from the Google, so you can use these things. Okay, so if you don't have any question, so we try to take a look at your example, test example lah. So this one how we want to program. Kalau you nak belajar, if you want to learn the program from scratch, use this book. Use Randy and Sue Ellen Hock book. So this one, suppose last time I just copy type, because when you copy paste you got a problem because some the notation here is not compatible with MATLAB, basically got the font and so on and so forth. When you type it back, so you can see how you can learn how the GA is been programmed, how you want to use mutation, as well as how you want to use the crossover. So it's a very good book. My PhD is using this book. Okay, I can show you my program. Basically, tengok adik lama dah tak buat. That. This one is economic dispatch. Okay, so this example is using a simple cost function. Okay, as I said previously, if you look at my paper, banyak sangat ni. Okay, it's my paper. The recent one is 2019 conference paper. Okay, this one. Tak boleh buka pula. Ini proxy boleh pakai tak? Tak boleh. Okay, this is my paper published in 2019. Okay, this is what I've done. I'm using a new application, new algorithm. This is my algorithms. So this is what we have done in class, right? We use the quadratic functions. So what if we have okay, this one I think the coefficient function is okay. So this one is the cost function, but the problem of this function, normally we try to make sure that the economic dispatch problem is close to the practical one. So that's why sometimes they put another constraints. So this one is the equality constraints. Summation of the generator must be equals to the load and loss. And then this one is loss calculation, how you calculate the loss. And then this one is an inequality constraint that your algorithm or the solution or the optimizer must make sure that your selection of the generator is not out of bound. And also is so, like I said here in the paper, to cater the ED problem as close to practical constraint, practical operation, so there is in terms or the problem of RAM rate limits. So they will change your results accordingly, as well as we call it prohibited operating zones. So in generators, when you learn about the power generators, especially in the thermal power generators, so there is some region that cannot be operated. Okay, as this here, as you look at here. So this is our cost function. It's supposed to be smooth, right? But when we have the prohibited zone, the best way is to avoid use the generator output at a certain values. So this is the prohibited zones. So when you do the optimization technique, you apply GA or any other optimizer, when the selection is fall in this region, so what we need to do? So we can use we can ask the optimizer to select whether at the boundaries values. So in order to make sure that our solution not operated in the prohibited zone. So this is the quite practical problem. So this is what I've done. Okay. So I think this one is similar with the Hadis Sadat. Okay. So I have compared with the PSO. MFA is a most modified 5-flag algorithm. MFO is the most flame optimizer, and BMO is my algorithm. So basically this cost is quite closer, but it's much better. Okay. So that one is 6 generator, and then I implement in the 15 generators. So this one is 15 generators. Okay, if you remember, in my video previously, that we calculate one by one, right? So when you have the MATLAB, it's quite easy. Or net, when you calculate even 4 generators, alternatively it require very large computation, ataupun you need to calculate alternatively. It's quite some time. So what we have a 15 generator, so you have 15 variables need to be optimized. It's quite big. Okay, so this is an example. And other example is we consider we call it instead we have the simple smooth cost function. So sometimes we have the system consists of, we call it valve loading effect. So to make that your curve is challenging by including the sine function. Okay, sinus function. So the equation is like, I think this equation is at balik buku mana. Saya tengok here. See this one. Okay, instead we have a simple quadratic functions. We put another coefficients D, and E to make sure that your system as close as practical one, which has valve loading effects, we call it. Okay, so this one is what we have done. If we have the quite challenging problem, this one. So we have not only for the quadratic function, it is also added with the valve loading effects. Okay, when your valve is open and closed, so that's why you can get your non-smooth quadratic functions. So this one is using 10 generators. This will have 10 generators. But this problem is, we call it, we not consider the economic dispatch only, we consider for emission dispatch also. So this one is quite advanced. Okay, so the term is economic emission load dispatch, because in power system, there is when we consider the economic dispatch, there is a rival of economic dispatch. We call it emission dispatch. The problem of emission is it is contradict each other. Okay, this one, let's say this is our fitness function for the cost, and then the fitness function for the emission. It is contradict each other, which makes the system very unbalanced, meaning that when you want to minimize the emission, this one, the emission is minimized, the cost is maximized. When you want to minimize the cost, this one, the emission is maximized. So this is contradict each other. So some people use multi-objective, we call it multi-objective. It's quite complicated, multi-objective, because two objective, we have two objective, cost as well emission, that contradict each other. So multi-objective, we have two objectives, is called, we can use multi-objective. So it's quite complicated already when we have the two objectives. Okay, so there is a certain research that use multi-objective research to solve the power system, especially when we consider economic dispatch as well as emission dispatch. Okay, so my research is not yet implementing the multi-objective, because I'm just using the simple linear equations. So let's say we have this one is your cost function, this one is emission function. It's quite similar because it's quadratic also, but the coefficient is contradict each other. Okay, so you have similar PG1, PG square plus PG plus J, but you have exponential function here. And then to make it simple, we call it the price penalty factor. So in order to make sure that your equations is a simple lah. Okay, so that's why this one is just a simple solutions. So this is the recent publication, because I am the inventor of the Badan Cosmetic Optimizer. So basically, what the optimization problem I try to solve using these algorithms. Okay, you can download. Basically, the Barnacle also is I just upload in the internet. You can learn this thing also, but it's very new. But has been accepted. Alhamdulillah, has been accepted by the community of the optimizers. This is my recent publications. This one is the first publication in journal that quite impact in engineering application of artificial intelligence. You can go here. Okay, has been published here. The novelty of barnacles, and then the rest is I apply. This one is journal for the extension of economic dispatch is, we call it, it's not extension, it's the origin problems of economic dispatch is from the optimal power flow. So now my research is implementing the new algorithms to solve the optimal power flow, but now I consider the renewable energy. So this is the recent publications that this one is ISI also. Okay, that consider the this one I consider the wind and solar generations. And my recent publications has been published in control engineering practice. This one is I consider wind, solar, and small hydropower. Okay, it's quite this paper is about, I think, 20 pages. It's like a thesis already. This is due to COVID last time this year, right? So I don't have any task that I really need, so I just do my paper and research. This is my publication. See, it's 20 pages here. So similar, this one, as you can see just now, but the optimal power flow is very broad. It's very broad. So what we have learned in power system in your discourse, if you just part of it, is economic dispatch. So we want to minimize the cost. So optimal power flow is not only minimize the cost, it's also minimize the loss as well as minimize the cost and emissions. It's combined. But now is we implementing the problem with the presence of renewable energy. Okay, so this one is that the presence of renewable energy. So what we have done in terms of generation of renewable sources. So this one we have cost for wind, cost for solar, as well for cost for the solar and combined hydro generation. So this one we implement this system. Okay, so we have the thermal generators. This one the conventional generators, and then we implement the solar. wind, solar, as well as the combined solar and hydro, small hydro power. So what happened in the system? So we implement variable fitting and log normal for the solar, and gumbel fitting is for the river flow rate, river flow rate. Then we capture, because the power of renewable energy is uncertainty, right? So we have depend on the solar, if we depend on the sun, and then wind depend on the wind speed, and hydro will depend on the flow rate. So this one is uncertainty that we need to consider. Okay, so this is 30 bus generators. Okay, it's modified because at 30 bus you can get the data online as well as in the hadis adat book. And then why this paper is very long, because the reviewer asked me to test about in the other system also, so that's why I implement in 57 bus. This one is 57 bus. Okay, so you have typical generators. This one is a conventional generators. Then we have solar, wind. We have solar, and as well as the solar and combined solar and hydro generators. So this one is 57. So this is algorithm that has been implemented. My algorithms compared to MOSFLAME, compared to PSO. Okay, so basically what we want to learn, we want to find because we have three cases: minimize the cost, minimize the loss, as well as minimize the combined cost and loss. Okay, there is another objective function. We want to minimize the voltage deviation, and also we can use multi-objective to solve this problem. But at the moment, I'm just using the single objective. So this is the case references. Okay, so 20 pages. This one 20 pages. I think this one 15 pages. If you interested in this research, I think this one. Can I see 15 pages? This one is only consider wind and solar only. So now there is several papers that I just consider solar only. So during the COVID, I have prepared 7 papers to be published. Now I think has been published about 3, so waiting for the four papers. Okay, that is what my research is all about. Okay, so what we have learned here is just a small pass or small it's a piece from the optimal power flow problem, which is the economic dispatch problem. Okay, so any question? If you don't have any question, we try to look at the example of your test, because I plan to do test another 2 weeks. Is it okay? 2 minggu lagi.
Boleh.
Boleh ya? So because that time is, I think is Christmas, right? So saya nak balik kampung. I'm going to back to my hometown. So I will do the test there. So we try to look at example for the, I think the kid, if you can do the test, the example for the previous semesters, supposed to be no problem lah. So let's take a look the example of quiz of the test.
Betul, test during class ada.
During class.
Okay.
Let's take a look example for the test. Mana? The previous semester. This one is last year, right? Okay, let's take a look at this one exam. This one is final, this one is test. Okay, this is the example. I think this one we have discussed this one, right? In the ANN. I think this semester will make not so complicated like this. It's just a simple. Okay, let's take a look at this example. Okay, your test is until GA. So next week, next 2 weeks your test, and then final week we will cater for the DE, for the DG problem. So let's take a look at this example. So continuous genetic algorithm is used to solve the economic dispatch problem for 3 thermal generators. You have 3 generators. This is the fuel function in terms of ringgit Malaysia per hour of these 3 thermal units are as follows. So this one is your alpha, beta, gamma, right? A, B, C. Don't be confused, because kat sini A, B, C is square, right? But in the program MATLAB, I think it's different. A is the C, B. Okay, don't be confused. This one is A, B, C, but in the test, in the this one is A, B, C. Oh, this one alpha, beta, gamma. So don't be confused. Normally there is a lot of floating numbers here. You need to times the p square. Okay, don't be confused. So you have alpha, beta, gamma, or A, B, C in the MATLAB. A, B, C. Okay, so you have 3 generators. Sudah. Ya. So my pen is not working. Wait. Okay. So we have 3. Don't forget this one is alpha. In my note, this one is alpha. This one is beta. This one is gamma. But in MATLAB program, this one is A, this one is B, this one is C. Okay, this one in MATLAB. This one is alpha, beta, gamma. So you have these 3 functions. We have 3 generators, F1, F2, and F3. So this one is P1, P2, P3 in megawatts. So the output are subject to the following limits. So this is the equality constraints. This one is the minimum. This one is the maximum for P1. This one is minimum for P2. This one is maximum for P2. This one is minimum for P3. Tinggal silap. Then this one maximum for P3. So the real power loss, so for the simplicity, we just use the simple terms. As you can see here, that your loss is just associated with the P1, P2 and P3. This one is because I want to make it simple. Because your P1 is, we call it the select generator, right? So meaning that the P1 is depending what happened in the, because we want to cater the equality constraint just now, as I said. If I put this one is not, is the dependent, is quite problem to do the calculation in order to get the error or your loss or your equality constraints 0. Okay, so you have P loss. This is the function of P loss, where the function is 0.0001 P2 square plus 0.003 P3 square megawatts. The load demand is 300 megawatts. So this one is your PD. P1 is treated as a slack generator. Suppose 2 chromosomes have been selected for mating, which are expressed as follows. Okay. This is what we call the floating numbers, ataupun we call continuous GA in the notes. Because our representation is not the binary number, our representation is floating numbers. Okay, so this one represent for P2, this one represent for P3. Okay, this is one selection, mom and dad. So the combination of extrapolation and crossover method has been used in this problem, where your P new is Pm alpha minus P beta, Pm alpha minus Pd alpha, where your alpha is given like this, and then the offsprings are generated as follows. This one P new, Pd, P new, Pm. Okay, so what is the total cost? What is the total cost for the evaluation function of the selected chromosome? So what is you need to do is number one, so this is our selected chromosome. These two is our selected chromosome. So apa yang perlu you buat sekarang? What you need to do is you need to calculate the cost. To calculate the cost, you need to know what is your P1, what is your P2, and what is your P3. So you need to we call it decode it. You need to decode this value. Okay, so mom and dad, you need to calculate what is your okay, suppose two chromosomes have been selected. So what is the total C1 for the function evaluation of the selected chromosome? And then what are the cost new function? Okay, so wait. So you need to calculate your P2 and P3, right? First, you need to calculate mom, the selection of mom, right? So what you need to do, you need to evaluate evaluation of mom chromosome. Okay, so we know our mom is, this is P2, this is P3, right? So we need to find the P2 value. What is your P2? P2 equals to 0.75 times the generator 1 limit is, this one is max, this one is min. So the equation is times max, the offset plus minimum, right? So the offset is 150 maximum minus minimum is 15 plus minimum 15. So berapa dapat? How much you get? Oh, bukan call lah. Or 15. Need to look at P2 because now it's P2, right? P1 is our select generator, so P2 150 and 15. So 0.75 times your max minus your minimum plus your minimum. So you get 116. 0.25 megawatts. And then you can find your P3. P3 is 0.55 here. 0.55 times the max is 150, minimum is 10. So here is 150 minus 10 plus 10. So you get 87 megawatts. Once you get this thing, you can get your P loss, because these two must be included in your loss code function here. P1, P2 and P3. So you can calculate your P loss equals to 0.0001 116.25 square plus 0.000187 square. Okay, this is the equation, simple equation for the loss. So you can get your loss. Okay, you can verify the answer. Your loss is about 3.6221 megawatt. Okay, until 4 iteration, 4 decimal point, you need to calculate until 4 decimal points. So once you get P loss, we know that our summation P1 plus P2 plus P3 must be equals to P load plus P loss. So we know already our P2, we know already our P3, we know already our load. Our load is 300. We know already our loss, 3 something. So from here you can find your P1. Okay, your P1 is 100.3721 megawatts. Okay, bear in mind when you do the calculation, I think it's supposed to be no problem, because in GA, because GA should be not out of bound. Because when you do the encoding, your value is normally between 0 and 1 for the continuous genetic algorithm. So basically it's not out of bound. Okay, meaning that 0 is 10 or 15, 1 is 150. This is the range. It's supposed to be not more than out of bound. So that's why GA is supposed to be not out of bound, because this one, as you can see, 150, and then this one is 87, is less than 150. Okay, so your P1 is 100 also. So from here you put all the value, P1, P2 and P3. This one P1, and then your P2, then your P3 into the cost function equations. Put here, put to here, so you can calculate your cost. Okay, so your cost is equals to what I got here. So you can verify 2529.15 ringgit per hour. Okay, you put P1, P2, P3 in these equations, sum it all, summing. So you get 2529.15 ringgit per hour. This one for mom chromosome. Okay, next you need to evaluate for the dad chromosome. This one. Okay, your dad chromosome 0.33. Similar, here is 0.33 times 150 minus 15 plus 15. You get for that, this one for that, your P is 59.55 megawatts, P2. And your P3 is 40.8 megawatts. So you can verify the answer. Next, you calculate the loss, put these two value into here, you get your loss. Okay, your P loss equals to 0.8540. From here you can get your P1. P1 is 200.504. Okay, but this is the problem because of your P1 is already out of bound. Okay, your P1 is out of bound, meaning that you need to pack here. Okay, you can pack, supposed to be you need to pack. I think I changed the value word. Wait, yeah, I think I changed the value. It's not 150. This one is 250. I don't want to pack. Kalau pack dia akan cepat susah depan. So this one is 250. So this one is not pegging. So from you get P1, you get P2, you get P3, you can get your cost. The cost is okay, you can verify the cost. The cost is 2795.99 megawatt. Ringgit per megawatt. Ringgit per hour. 2795. Okay, this one for the selected mom and dad chromosome. Okay. Okay, let's take a look at B. Okay, what is the total cost of CT, F1, F2, F3 for the evaluation function of generated offspring? So similar. So this one, you need to calculate your what happened here. What happened here? So you need to calculate your P new using the value here. Okay, so your P new, we just use the equation. P new equals to P mum alpha ni, minus beta P mum alpha minus P dad alpha, where your alpha is 2, beta is 0.25. Okay, so P mum alpha is 7. Okay, you can calculate your P new. P new 1 is 0.75, 0.25. Use all the information here. Okay, beta is 0.25, alpha is 2. Alpha is 2, meaning that this one, mom 2, and then dad 2. P2. Okay, so 0.25, 0.75 minus 0.25 times 0.75 minus 0.33. Because 0.75 if your mom number 2, this one is dad number 2, this one. Okay, so you do this expression, you get your value 0.645. Okay, and then you can calculate your P new 2 is P mum number 2, 0.75 here. Plus, this one plus 0.25, 0.75 minus 0.33. This one is minus, this one is plus. So you get 0.855. Okay. Once you get this value, can calculate your offspring, your new offspring 1. Use this equation. P new 1, PD3, P new 2, PM3. Okay, so dia terbalikkan je. So P new 1 is 0.645 that you have obtained here, but your here is your value of that. That is this one. So 0.22. Okay, and then your offspring 2 is 0.855. This one is mum, 0.55. Okay, and then similar, find your P2. You need to decode tadi, like previous one. Then you can find your loss. Then you can find your P1. Then you can calculate the cost. Okay, this one, the value is 27. You can check later. 2712.65 ringgit per hour. Similar this one also, you decode to get your P2 and P3. Okay, and then you cut P loss. Then you can calculate your P1. Then you calculate the cost. So the cost is 2532.47 ringgit per hour. Okay. Next, if the mutation is imposed in variable P3 for one of the new offsprings, discuss the result of implementing the mutation if the mutation is 0.777 times P3. So you need to select, this one is mutation, new offspring, right? So these two have mutation antara dua, between these two. So you just times 0.777 with this value, and then you calculate your, again, you decode, calculate P loss, calculate P1, and calculate cost. You just select one of them. Then you can see whether your, when implementing the mutation, the result is better or worse. Okay. Any question for this example? This is the previous. This is a semester. Previous year. 2019, 1819, semester 2. And then your test should be like it's quite similar like this. Okay, any question, class?
So betul 19 sampai 12 saja. I mean 20 26
yeah.
kan?
26 lah. Okay. Okay, let's take a look. This is example if we have floating numbers. So last time I give the floating numbers in test, and final I give the binary. So let's take a look at the binary. Binary final. Ini dia. Jawapan dah. Oh, ni jawapan. Jawapan sebab template. Mine. So this is the final. Kita dah discuss yang itu sama. Okay, let's take a look this one. This one. Okay, this one we use binary. So the problem is you want to decode. Basically, you want to decode. When you do the program MATLAB, you want to encode first, and then you do the decoding. And then similar, you do the GA function, and so on and so forth to get the power, the results. But for the purpose of the examination, Basically, I just want you to understand how you want to implement how you want to calculate. Basically, the economic dispatch is simple. You find the P1, P2, P3, and then you do the calculations to get the cost function, to get the minimum one. So I think it's quite similar from the previous example, but now the representation is binary. Okay. GA is used to solve economic dispatch for 3 thermal generators. Suppose 2 chromosomes have been selected for mating. 1 point crossover is adopted for each variable shown figure 2. Okay, 1 point crossover. So meaning that this 3 is crossed over to here, this one is bring to here. Okay. And then the field function, this one, I think should be similar. I think this one also 250, tak apalah, kita tengok nanti. P1, P2, P3 in megawatts. The real power loss generation is P2 and P3. So similar. Your P1 is slack generator. So meaning that we need to decode P2 and P3. Once you decode P2, P3, you got the P loss. Once you got P loss, you got P1. Once you get the P1, you can calculate the cost. Similar. So the problem here is now, instead of just now is floating numbers or continuous number, but now our representation is binary. So how we want to calculate? Sama tak jawapan ni? Ini jawapan. Oh, this one I just change. Never mind. We try to look at this example. So how you want to do this one? Okay. So how to do it? First you need to do decoding. Decode. This is the encoded value, so you need to decode. So P2 is 1100, P3 0111. Okay. Okay, just remember your P2 is between 15 and 150. P3 is between 10 and 80. So this one you need to use the representation because we have 4 bits. 4 bits meaning your minimum is 0000, right? So 0000 is 15 megawatts. 1111 is the maximum, right? Is 150 megawatts. So we want to find our value in terms of this one is quite slightly. You can say this one is your X. You need to times with your maximum minus minimum. You divide by your bits. You have 0000 is what? How many bits? Maximum is what? 111 is? Kalau you change from the binary number to the decimal number is what? 1111. This one 2 the power of 0, right? This one is 2 the power of 1, 2 power of 2, 2 power of 3. 2 power of 3 is 8, 8, 4, 2, 1. So it's about 15. So 15 lah. Okay, the maximum is 15. And then you need to add with the minimum value is 15. Okay, remember 150 minus 15 divided by 15 plus 15. X is your representation. Now is this one is 2 power of 0, 2 power of 1, 2 power of 2, 2 power of 3. 1100 meaning that this one is 8 plus 4 is 12, right? Betul tak? So when you do calculation here is 12 times 115 minus 15 divided by 15. 150 minus 15 divided by 15. So times 9. This one is 9 plus 15. So this one is your P2. You get 1, 2, 3 megawatts. And then for the P3 is 0. This one is 1, 2, 4, right? 4 is 7. So your P3 equals to, but your P3 now is, the range is 80 and 10, right? So this is 7 times 80 minus 10 divided by 15 bits. The maximum is 15 plus 10. So you get your value 42.6667 megawatt. Boleh? Binary ni dia, because we use the binary number, we need to change, we need to decode the binary representation into the decimal value. So we use this one. Okay, remember x times your maximum range minus minimum range divided by how many bits? You use 4 bits is about 15, right? If you 3 bits is 7 lah. 111 is 7. If you 5 bits 11111 apa? Ini 32 tambah dengan 15 7 47 lah. Okay, so depend on how many bits. The bigger bits that you use, the quantization is minimum, meaning that you make the quantize is very minimum, because the quantization, right, compared to, but it become complicated lah, because you have many value. You have for example this one, you have 4 value, right? So this 4 value, when you do the crossover, so sometimes the knowledge is slightly different. So that's why it's not much different and require very long iteration to get the optimal results. That's why GA is quite slow compared to others, because first you need to encode, decode, and then depend on what numbers that you use, whether you use binary number, whether you use floating numbers, or sometimes people use round numbers. Okay, instead of binary, they just represent in terms of round numbers between 0 to 9. So but that one is depend on the applications. Okay, so you get your P2, you get your P3, then you can calculate your loss using this expression. So here you get your loss. You can verify the answer later. I got 1.6949 megawatts. So from here you can get for my P1, because my P1 plus P2 plus P3 equals to demand plus loss. So I get my P1 equals to demand plus loss divided by P2 and P3. So I got my P1 is 86.0283. So I have P1, I have P2, and I have P3. All this value I put into the equations, these equations, so I can get the cost. The first cost is 2361.21 ringgit per hour. Okay, this one is for the chromosome number 1, because the answer, the question is what is the total cost for the selected chromosome, these 2 chromosomes. Similar from the previous example, you need to calculate this chromosome and this chromosome. Next, you need to calculate the child or the offspring. Okay, so I just not sure, you just can you do it by yourself. This one 1010, you change to numbers is I think 10. 10 times 9 plus 15, you get something. This one 1010 also similar. It's 10 times 80 minus 10 divided by 15 times 10, you get something. So now we want to find your offsprings. Offspring number 1, because this 2 is changed, meaning that your representation is 1100 for P2, for P3 is 1011, because these 3 bits only change. Okay, so this one is offspring number 1. And then offspring number 2, instead of 101, now it's changed already, is 111, 0, and then 1010. Okay, next, calculate you need to decode the value of this one, P2, this one, P3. Decode using this expression for P2, and then using expression for P3. Next, you calculate your loss, then you calculate your P1. Once you get your P1, P2, P3, you calculate your cost. Similar with the offspring number 2. Okay, that is the question number B. And question C, if mutation is imposed bit number 3 in variable P2 of one of the new offsprings, discard the results. Okay, bit number 3. So you offspring number 3, offspring number 1, bit number 3 at P2, right? So P2, bit this one, bit number 1, bit number 2, bit number 3. So mutation happen. What happened in mutation? Instead of 1, you have 1 bit number 1 here. When we have mutation, it changed to 0. So we become the mutation. This one we apply mutation. Instead of 1100, become 10001011. Okay, similar. And then you calculate your P2, P3, and then calculate your loss, calculate P1, and then you calculate the cost. See how whether the result is improved or worse. This one for the child offspring number 1. And then offspring number 2 also, this one 1110. You do the mutation here, become 1010, meaning that this one is similar with the chromosome previously. So sometimes it's not changed. Okay, when you implement the mutation, sometimes the result is better, sometimes the result is worse, or sometimes the result is not many changes. That is happen in genetic algorithm. Okay, any question? So we have discussed about how to implement the GA using MATLAB or using toolbox, and then we have discussed example of your test as well as the final exam. I think the question is quite similar. It's a matter of I change maybe I change the representations, or instead of 3 or 4 bits, I use 3 bits or 2 bits, depend on what, because I think this is a simple one. So any question, class? Soalan? Sedang setengah. Any question? Okay, so If you don't have any questions, so I just proceed with the new topic ah. Oh wait. Your assignment just now submit dah, semua submit dah. Saya tak tahu. Assignment satu. Okay, 3 dia submit. Siapa tak submit? Oh, Daya tak submit lagi. Submit ah, kena submit.
Okay, betul.
Right, assignment ni the 15%, 10%, 20 ya. Test 30. 15% assignment. So please submit. So you nak assignment ke nak discuss next topic? I think assignment lagi at the end of the semester lah. Boleh tak? Bukan, after test. Boleh?
Okay, boleh.
So next 2 weeks is test. Then I give you another assignment. Assignment you can select. So we have discussed the GA and we have implement the GA in MATLAB to solve the economic dispatch. So later we will discuss the DG problem and then we implement the DG in MATLAB. So the assignment is tukar lah. Assignment you can choose whether you want to use DG or DE to solve whether I think to solve the DG problem lah, because okay, later lah I decide. Okay, we try to look at the next topic, the final topic before you go for the test. I think as I said previously, your test is quite similar with we have been discussed. Okay, and at the meantime you can do by your own, and if you have any problem you can WhatsApp. You can WhatsApp. I think better use WhatsApp in group lah, so everybody can know what happened, what your question are. And then we try to look at the example, the new topic, the final topic. Okay, this one I think just proceed until less than kita cuba dalam sejam lagi boleh?
Okay.
Sebelum pukul 12 kita stop lah. Okay, so we'll look at the final topic. Okay, the power system implementation to solve the, I think this one is just repeat what we have discussed or what I have discussed in the video. So later we will have the curriculum review to see either to implement a new algorithm or not. So never mind. So let's take a look at this topic. So what we have done in GA to solve the economic dispatch basically is the optimization. Okay, that is the optimization. So what we have discussed about ANN, or now the term is deep learning, to solve the load forecasting. That one sometimes the people said is that is a machine learning problem. Okay, so in this class you learn about ANN to solve short-term load forecasting. So this one is prediction. Okay, and then we learn about GA to solve the economic dispatch problem. So this one is the optimization. And then we extend the optimization problem in the power system. Another quite popular problem is the DG problem. We have DG to be implemented. The problem is to find the location as well as the size of the DG at the distribution system. Okay, distribution system. This one is to solve the ED at the generation stage, right? Generation stage. This one at the distribution system. So now instead of GA, we use DE, another evolutionary algorithms that quite popular. People still using this algorithm and still improve the algorithm. So we implement DE to DG problem. So your assignment later, I will decide whether, I think you we swap this one. So you can change whether to use GA to solve DG or use DE to solve ED. Your assignment. Okay, never mind this one. I will show you the details how to program in MATLAB also. Okay, so optimization is everywhere. So this one, this two is optimization. Basically in AN also we have optimization. That is the research in ANN, because you want to determine the value of weight, right? The weight of the neurons. So instead of you use the gradient descent or you use the back propagation algorithms, you can use GA or DE or any optimization problem to determine the optimal value of your weight. So that's basically ANN also consists of the optimization problem. Okay. That's why I said this optimization is everywhere, from engineering design to business plan, or from writing on internet to holiday planning. So it is optimization. Okay. What is optimization? Basically, you want to achieve certain objective, whether single objective or multi-objective. Okay. Normally, we want to optimize something to such as profit, quality, and time. So depend what problem that you have in hand. So mathematical optimization or programming is the study, such planning, and design problems using mathematical tools. So there is a hard computing as well as soft computing. What we've done until now is a soft computing. Okay. Hard computing is a very hard derivation of mathematical expressions. You do the partial derivations and so on and so forth. But when you do the soft computing, we just mimic the nature to solve the optimization problem. Okay, the mathematically speaking, it is possible to write the most optimization problem in the generic form, where we want to minimize the function. This one is output, or y sometimes you could say, and then the x is your input. Okay, I is from 1 to m is your dimension. Call it dimension. How many dimensions you have? Subject to your equality constraints. Why equality? Because you must fulfill the equal here. That's why our economic dispatch, your submission PI must be equal to demand plus loss. Okay, this one you call it equality constraint. And then we have inequality constraints. In the economic dispatch also we have inequality constraint, where your generation must be between some value to some value, some extent of value. Right. So this one is inequality constraint. That is the meaning of equality and inequality constraints. Meaning that the solution that you have found, or the solution of the optimizer found, must be fulfill these two constraints. Okay. And then X is your inputs functions or vectors, in terms of vectors. Okay, whether it's continuous, discrete, or sometimes we call it both discrete and continuous. For example, is ORPD, optimal reactive power dispatch, because you have a discrete value as well as the the round value. Okay, consists of both. I call it combinatorial problems. Okay. So history, humans' approach to problem solving has always been heuristic or meta-heuristic. What is heuristic or meta-heuristic is by trial and error. And 1970s, 60s and 70s are two important decades for development of evolution algorithms. This one is due to the after World War II. World War is 1940 something, right? So until 60s, it's a boom because we have a Cold War and so on and so forth between America and Soviet. So they're implementing the artificial knowledge. Similarly with the Japan is studying the ANN as well as a fuzzy. Okay, there is a research. Basically, that too basically is for the normally the intelligence is used in the war, for the purpose of war, to develop bomb and so on and so forth, or to decode what is the transmission from the their opponents. Okay, and then we have John Holland and company developed GA. Last time they didn't give the GA. I think they just nature inspired something. If you put the John Holland, they didn't mention the genetic algorithm until the student of GA, I think Goldberg and Michael Weiss, they stated they named the algorithm as a genetic algorithms. Okay, and then they try to go for the aerospace engineering. Okay, the race to explore the space between the Soviet as well as for American. And then for gel, we Owen and Walsh developed evolutionary programming. This is the other evolutionary algorithms. It's quite similar to basically the extension of GA. Okay, the mentioned methods has evolved into much wider discipline called evolutionary algorithms or evolutionary computations. So, and then ANN, McCullough-Pitts, this one is the earlier one. And then 1963, Vipnik for machine learning problems. And then they proposed simulated annealing. This is the old algorithms, 1983, Tabu Search, 1986. And 1992, Marco Dorigo finished his PhD on ACO. This one is Ant colony. Ant colony optimization. Normally for ant colony is very powerful for path. Normally in computer science there is traveling assessment problem, right? So there is normally for the path. They're using the ant, they mimic the ant nature to get the minimum, the shortest path for the salesman to go each town by the shortest path. And then 1992, John R. Koza proposed genetic programming. This one is extension. Okay, which laid the foundation in a new area of machine learning and revolutionizing computer programming. So I never done the genetic programming. ACO, I attempt the algorithm, but not yet because I don't understand some terms that cannot be because I can see that this is very superior in terms of the when you have problem that have a route to get the optimized route. But in terms of power, I think there is a certain researchers have been done to solve power, but I don't get any. There is a motivation for me to implement this thing. But just I think the previous week or last week, there is a person from China. They condemned the Mirjalili algorithms because they said that the Mirjalili's PhD is based on the Grey Wolf optimizer. And if you look at my website, I use this algorithm to implement to solve the economic dispatch, the solve the RPD, and many more. In fact, my two students, PhD student, has been implement the GWO into topic of protection, relay coordination. Okay, my master student to solve GA, to solve ED using GWO. But that guy is condemning the Mirjalili's works because he said that this work is not novelty. I don't know, but when I discuss with our Deputy Dean, Dr. Mawadi, normally China sometimes they're very skeptical. They try to make instead of meraikan, dia menghentam orang. But they said that Dorigo also haven't analyzed all the recent algorithms, and then they critique a lot of algorithms. But for me, as long as the algorithm can perform well and solve the problems, so should be no problem. Okay, never mind. And then 1995, PSO, particle swap optimization, has emerged, developed by James Kennedy, Ken Hart, Russell C. Eberhard. So PSO inspired by swap intelligence of fish and birds. So this is when this one is emerged, they change the term. Okay, they implement the swap intelligence. Okay, from the artificial intelligence, they go for the swarm intelligence. they go for evolutionary algorithms. Now they go for the computational intelligence. That's all basically is quite similar. It's just a terminology only. Okay. And then 1996-97, Stone and Price developed DE. DE stand for differential evolution. Okay, differential evolution. Then they said that the GA is more, that DE is more efficient. I have never done the DE because there is various research has been done. Instead, my paper also referring to the guy from the NTU, the Indian guy. He do the PhD, graduated last year, 2019, to solve the OPF problem using the improvement of DE. Okay, people, when the new algorithms is emerged, when the new algorithm is come out in the literature, people will try to improve. Normally they will improve. They call it maybe IDE, improvement of DE, and then they implement in the multi-objective MODE. Jadi so become multi-objective differential evolutions. So and then sometimes people improve the modified the multi-objective algorithm. So similar with my algorithm, I have implemented the I have invented Barnacle's matrix optimizer. This is my research. Uh, this is my algorithms. And then review, I think about last week or last 2 weeks, people had already implemented these algorithms in if you go to Scopus, this algorithm, people has invented the new when you are out from the UMP, you can use easy proxy. Okay, you know that, right? So but now Scopus, okay, Scopus. So this is me. This is my paper. Where is it? Now it's 20. This one. This is my paper. Has been cited by not this one. Access. Last time I got the people has been implementing my algorithms. So when the algorithms come out, people is using the algorithm. They know already that the algorithm must be lack of something, so they improve the algorithms, and then the people go for the modified algorithms. So that's why it's how the algorithm is being and evolve. I think I share with a friend. this one. Up to the November. Okay, so this one, I think it's my email. Okay, this one they use I open this thing right. Yeah, I see. So this is never mind. So basically that is what is happened when the algorithm is emerged. So people try to improve the research gate. The best of research gate because they always implement okay. This is the paper citations. This is mine. 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 Okay, so that's what happened. So 1996, 97, DE, and 2001 we have harmony search. Okay, all I can say that all of the algorithms I've tried to implement solving the problem, especially in economic dispatch. Okay, 2004, as Nakrani Tove proposed honeybee algorithm. So for B also there is a lot of research has been implemented. There is ABC, artificial bee colony. BA is palm, DT palm from the UK, I think one. ABC is the nature of how the bee finding the foraging. Okay, this is a foraging behavior. And then there's a proposed honeybee algorithm. I think this is also the foraging. So normally when we talk about the nature inspired, they will use two nature. One is foraging, how the insects looking for the foods or something for the mating, how they mate. This is two algorithms that normally people tend to do. Okay, and then 2008 Yang just enough recently developed firefly algorithm. So this one is firefly, the way how the firefly the intensity lights to attract for foraging as well for the mating. Okay, and then there is many other materialistic has been proposed. We have GSO. GSO, I think the glowworm search algorithm. It's a worm. This one invasive weed. IWD, I think water. Then there is a monkey search. You have gravitational search algorithm, and then this one is bat algorithm. Is from the Yang also. Quite glamour, right? Because of COVID-19. It's from the bat. And then 2012, you have a differential search algorithm. This one from the movement, walking movement, or Bohemian rock walk, I think. So there's a lot of research. But there is a lot of algorithms that available in the literature. So basically, you need to select which one is the best to solve your problem. Okay. So let's take a look at what the problem for the DG problem. Okay, so DG is a quite the popular research. During my PhD time, people there is a lot of research in DG. Start my PhD 2008. So I think if we go for the conference, normally a lot of people tend to do the DG problems. Okay. So what is DG? DG, the problem of DG is we want to install the DG into the distribution system. So we need to look at the impact of the current or what have impact to the system. Wait lah. Hello, aku dah kelah. Aku dah kelah. Benda. Aku tahu. Tak apa. Tak payahlah. Ya, aku dengar kelah. Kau bincang sama mak. Okay, sorry. So what is DG? We want to implement the DG. We install the DG at the system. So supposed to be that DG will give you the impact of to minimize the loss. Okay. So what the problem of DG is, we need to determine the location as well as the size of the DG. So the objective function is to minimize the loss. This is one of the objectives. Basically, you can normally in power system, normally we want to minimize the loss or minimize the cost. So sometimes the people try to make when implementing the DG, they tend to include a lot of practical problems. So such as what happened in terms of the safety or protections, like relay coordinations impact to the system. Okay. So for this class, we will look at this problem. So we want to determine the location and size. Okay, therefore the factors of best location and sizing are among the important issues in the implementation of distributed generation in distribution system. So with optimal placement of size and sizing of distributed generation, maximum potential benefits could be obtained, especially to improve the performance. Normally we want to reduce the system loss. So once your loss is improved to minimize, so normally our voltage profile also can be improved. So this one I think have been discussed previously on it. So let's take a look at differential evolution. Basically, differential evolution is developed by Stone and Price in 1996-97. So it is based on evolutionary algorithm and can be considered further development to GA. Okay, it is stochastic search algorithm and with self-organizing tendency and does not use the information or derivative. So the advantage over GA, it uses real numbers of string. So that's why it's no encode and decode. So there is no sorting process. Okay. Because we just now we use the GA toolbox in MATLAB. So that's why we don't know what happened in the GA. Supposed to be there is a encode and then evaluation, and then they go for the crossover mutation, and then there is sorting process to get the best result at the top of the populations. So this one we will look at this in details using the DE in MATLAB. So let's say we have a D-dimension optimization problem. So D-dimension meaning that if you have, for example, just now we have 3 generators. So meaning that we have dimension of 3. So we want to find the P1, P2, and P3. So but in this problem, we have only 2. So we want to find the location, and then we want to find the size. Okay. So you have 2 variables to be optimized, or 2 dimension, where your location is round number, and then your size is continuous number. So this one you can consider that a combinatorial optimization problem. Okay. And then T is the iteration number. The vector can be considered as a chromosome or genomes in GA. So instead of compared to GA, DE have 3 steps only. It start from mutation, crossover, selection. Okay, it's quite different from the GA. GA start with selection, crossover, and mutation. Okay, and then mutation is carried out by the mutation scheme. Initially, you choose 3 random vectors, so they call vectors XP, XQ, and XR, and generate so-called donor vectors, mutant vector or mutant vector, donor vector or mutant vector by using the mutation scheme. So this one, where you have your F function, which normally set as 0.7. So you have this one, your V for the next, T plus 1 meaning for the next iteration, XPT, your variable for the current iteration, plus XQ. So this one is random vectors, XP, XQ, XR. Okay, it's the random vectors in order to generate new donor vectors. Okay, T represent for the current iteration, T plus 1 represent for the next iteration. Okay, so basically it just give a perturbation. We call it perturbation. It's just some slightly changes of the system. From figure, we can see the perturbation to the vector SP is used to generate donor vector, and is directed and self-organized. So let's say we have this, our variables. You have 2 variables, x1 and x2. This one is the minimum point. So what happened is, this is your F, xr2 minus xr3g. So basically what happened here is just a vectors that, this is the donor vectors, this is the current vector, that plus this one is, we call it the perturbation. Perturbation to for the vector to find the optimum point or the minimum point. Okay, this is how the D is obtained. And then the crossover. This crossover is controlled by crossover probability, normally set of 0.9. And this operation can be carried out in 2 ways, binomial and exponential. So for this class, we use binomial, where this is your UJI, T plus 1 is the next iteration. You use the VJI is your donor vector. Now you just change the J, I to J. If your numbers is less than the crossover probability. Okay, meaning that if more than, when you run at a certain iteration, your RI is more than crossover probability, so you just select the current value. Okay, so this one is how the binomial is used. Okay, this way each component can be decided randomly whether to exchange with donor or not. So for this one is example. So let's say we have, this is our vector, and then this is our donor. Target vector containing the parameters. So this one dimension, you have 7 dimension. So this one is your mutant vector. This one is call it trial vector. So let's say at the parameter number 3, when you do the random, it's less than the crossover probability, so it will change to the trial vector, meaning that this information will be transferred to this trial vector. Similar with the 4 and this one for the 6. So now your target vector become like this. Okay, this is the how the crossover is being implemented. Okay, next we go for the selection. The selection is similar with the GA. You select the most fittest for minimization problem, meaning that the minimum objective value. So that's why to select, you need to find you select your UI, meaning that your trial vector, if your fitness function less than the current fitness, or otherwise you maintain the results. Okay, the overall search efficiency is controlled by two parameters, F and CR, meaning that these two parameters that you need to tune in order to get the better results. Sometimes when you do the first run, you cannot get the results, so you run to second. That's why you need to do the tune for these two values in order to get the results. Okay, this is what happened in the differential evolution. Okay, so choose the target vectors and then random choice of two population members. This one the populations, and then number 3, compute weighted difference vector, and then you add with the base vector, and then you apply the mutation, and then you try the crossover, and then you do the selection. Okay, and then this is a new population. I think we will look into details. This one is code. When we want to implement the DG problem using the differential evolution later after your test. Okay, I think that's all for today. Any question, class? So next 2 weeks after Christmas, so I'll give you test I think 30%. So what will come out the test, not yet, I tak buat lagi. So basically the question is close, or is not similar, but I think it's close with the one that we have discussed in class for the ANN as well as for GA. Okay, I think for ANN I will give you the quite simple question, not as complex as the previous one that I have discussed with you. I think the neuron is much simpler. Okay, and then the GA, the question is quite similar, just changing maybe the bits. Instead of 4 bits, I use 3 bits, and so on and so forth. Okay, any question? And for the DE in MATLAB, we will learn after your test. Okay, we have, I think, in terms of schedule, so we have class today, and then 26 we have a test, and then 9th of January, right? So 9th of January. So 9th January, I give you assignment 2, and then I think that's all right. And then we have finished. 23 is the study week, kan? 23 January is study week. So we have 2 class more. 26 your test, 9 I will give you assignment. So assignment basically simple, because you can get the coding, and then you just simple write up about the problems. Okay, any question? Hopefully that you can cope something from this class. So later I will share with you the recorded video, so that you can refer back how to do the programming, as well as what we have discussed about the GA in test as well as in the final exam. Soalan kelas?
Doctor, if possible, can you share the previous test? And
yes. Later I show you. Later I share with you. I think with the I share with you the previous test as well as the final exam question.
Okay.
Okay. Okay, there is no other question. I think that's all for today. Thank you very much. Thank you for your attention. Hopefully you can get something from this class. So all the best. Assalamualaikum warahmatullahi taala wabarakatuh. Thank you very much.
Yeah.
Waalaikumsalam.
Salam.
Salam.